Okay, I'm going to walk you through a simulation that is a little difficult to understand, but it's a good one. So if you will take the time to try to really follow this, I think you'll get some insight that's really helpful. First of all, you have to watch the Mythbusters video. You really want to make sure you watch that. It's only the first 4 minutes of that clip. So if you'll watch that, you'll get a good background. So if you haven't watched that, you need to pause this right now, go back and watch the Mythbusters. So here's the data that the Mythbusters collected. And they found out that with a seed, a yawn seed, 9 out of 34 yawned. Without a yawn seed, 5 out of 16 yawned. The difference in those two groups is 4%, and they felt like 4% was a big enough difference that, yes, we can conclude there's a statistical difference between these two groups, that seeds actually do cause yawning. Now, just a quick note, this is not a p-value. That's not what this is. This is the difference between two sample proportions. So it's like p hat with a seed minus p hat with no seed. That's what this is. It's not a p-value, so don't get confused that, oh, it's less than 0.05. This is just the difference between two sample proportions. And we want to know, is this a significant difference or just a random difference? So we're going to approach it from a simulation. And I have some cards here that are going to simulate either people yawning or not yawning. I've got 50 cards that represents the 50 people that showed up at the Mythbusters booth. And our null hypothesis, of course, is always that there's nothing going on. There's no weird things happening. There's no difference, no change. So our null hypothesis is basically, you know, these 14 people that yawned would have yawned anyway. That's our null hypothesis, that there's no causation by seeding people to yawn. So our null hypothesis is this is what was going to happen anyway. It doesn't even matter that there was a seed or not. This distribution of numbers, 10, 4, 24, and 12, that's just a random distribution. That's our null hypothesis. This is happening by random, but this is our null hypothesis. Those 14 people out of 50 would have yawned no matter what. So here's what we're going to do. I have a deck, and you have a deck as well. You can either print it off from the PDF, or you could even use playing cards. You just need like 34 or 36 of one color, 14 of another color. That's all you really need to simulate this. But these are pre-printed with yawn and no yawn, so it's a little more helpful. So I got 50 cards, and these 50 cards have 14 that say yawn, and 36 that say no yawn. So I'm simulating the null hypothesis. I'm simulating the assumption that 14 of these cards or people are going to yawn and 36 are not going to yawn no matter what. In other words, just with a random distribution. What I'm going to do with my cards then is I'm going to do the randomization of this distribution. The randomization happens with simulating the seeding or not, because 34 people ended up getting the seed and 16 ended up not getting the seed. So I'm going to deal these out kind of randomly. I've been shuffling here for a few minutes. I'm going to deal these out randomly into two piles. One's going to have 34 cards, one's going to have 16 cards. And then I'm going to see how many yawned and how many yawned, and that's my simulation. I'm re-randomizing the 50 people into two groups of whether they got the yawn seed or whether they did not get the yawn seed. Now, just to speed things up, it's a whole lot easier to deal 16 cards than 34. So if I deal 16 cards on one side, well then the other pile is going to automatically be 34. So I'm just going to deal out 16 of these cards. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so I shuffled and I dealt out 16 cards. Now I'm going to look at them and see what the yawn rate is for these 16 cards. So if I turn them over and count how many are yawns and how many are no yawns, I will have one simulation. And you notice this is kind of a slow process. Normally we do this in class where everybody's doing it, and so it speeds things up a little bit. But it takes a little while to do it all by yourself. So I've got these split up now. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7. So it turns out out of these 16 cards, so I'm dealing with the 16 people that did not get the yawn seed. I've got 1, 2, 3, 4, 5, 6, 7 yawns. So I'm going to write that down. I got 7 yawns out of the 16. So if I got 7 yawns out of the 16, then out of the 34, there must have been how many? Remember, we started with 14 yawns in the deck, and if 7 of them ended up in this group, well, that means 7 of them ended up in that group. So now we just need to calculate the difference between these two percentages, and we should have another sample difference. So 7 out of 34 is about 20.5%, 20.6%, and then 7 divided by 16 is 43.8. And so 43.8. So let me start this over again. So I'm going to take 0.206 minus 0.438, and I get a negative 0.232. So my first simulation, I actually got a difference that was negative. You know, they got a difference that was just a little positive. I re-randomized and I got a difference that's negative 23. So we would want to do that several times. We would want to do this a lot. In fact, we would like to do this dozens or maybe even hundreds of times. And then we would have maybe an idea of whether or not 4% is unusual. So what we're going to do is do this lots and lots of times, and then we'll be able to tell whether we think this is significant or not. So stay tuned for a simulation that will speed this process up considerably, and you can see why. It's such a slow process of dealing cards out. We can speed this up with a computer and get at our answer pretty quickly. So that's just the explanation of how you should do it. You don't have to do it 40 times like it says in the book, but I would like you to do it a couple times and get a couple different samples of differences and just see what you think is true about the 4%.